Hello students, we are going to start the chapter Redox reactions. Okay, so in this chapter we will be studying, you also know about this, that yes, we study about oxidation and reduction. We have studied about addition of oxygen and removal of hydrogen in case of oxidation and reduction. We have studied in terms of addition of hydrogen and removal of oxygen. But in this chapter we will be moving on to the more elaborate level of the electrons. Okay, and then we will be seeing some more reactions in detail, and we'll be understanding it, how it is going on. Okay, so now taking from the initials, okay, let us take the classical idea of oxidation, which we have studied earlier also, that yes, there is addition of what? Oxygen, and we will be saying that yes, that is a oxidation reaction. Okay, and if there is removal of hydrogen, that is also a oxidation reaction. But yes, the new approach of oxidation is what? It is the addition of oxygen or electronegative element, okay, to a substance, or removal of hydrogen or electropositive element from a substance. Okay, for example, if we are talking about addition of oxygen, magnesium plus oxygen gives what? Magnesium oxide. Oxidation reaction is taking place. Very easy, yes, addition of oxygen. But yes, addition of electronegative element like magnesium plus what? Chlorine. It will give MgCl2, magnesium chloride. Here what is here? A electronegative element is being added. Okay, so it is what? Oxidation reaction. Okay, now coming to reduction. Okay, it is removal of oxygen and addition of hydrogen. You know this is the classical definition only. Okay, but yes, when we are seeing it to the new approach, yes, it is addition of what? Electropositive element and removal of electronegative element. Okay, so here you can see I have taken an example of this ferric chloride plus hydrogen molecule. What we are getting what? FeCl2 and HCl. Initially we had taken FeCl3 and now we are getting FeCl2. So here what is happening? One chlorine is being removed. So one electronegative element is being removed. So it is what? Reduction. Okay, now redox reaction. Okay, in a reaction simultaneously oxidation and reduction occur. This already you all know, this is the classical idea only, and this is the universal thing, that yes, in a chemical reaction what happens? In this simultaneously oxidation and reduction takes place. So students, we have studied about oxidation and reduction in terms of oxygen, in terms of electronegative element. Okay, now we are going to study in terms of what? Electrons. Okay, so redox reaction in terms of electron transfer reactions. Like if we are saying oxidation has taken place, it means what? There is a loss of electrons. Okay, now if we are saying reduction has taken place, it means there is gain of electrons. For example, suppose this is NaCl, okay? Okay, when it is dissolved in an aqueous solution, okay, dissolved in water, what happens? Na plus and Cl minus ions are formed. So what is happening over here? Na is giving the electrons, so there is loss of electrons, and yes, if there is loss of electrons, what is taking place? Oxidation is taking place. And here you can see this electrons has been taken by this chlorine. So what has happened to this chlorine? It has been reduced. So which process has taken over here? Reduction, because here gain of electrons has been taken place. Now if we are talking about oxidizing agent and reducing agent, okay, so you all know oxidizing agents are those agents when they react with some other substance, they oxidize that substance and itself gets reduced. And reducing agent is a substance, what happens when it reacts with any other substance, it reduces that and itself gets oxidized. Okay, so here when we are explaining in terms of electrons, oxidizing agent is the acceptor of electrons because it is itself getting reduced and it is oxidizing the other substance with which it is reacting. Okay, when we are talking about the reducing agent, okay, it is the donor of the electron because what it is doing, it is giving the electrons to the substance with which it is reacting, thereby reducing it and itself getting oxidized. Now let us study competitive electron transfer reaction. Okay, so in this we'll be taking example and we'll be understanding this topic. Okay, so here you can see a reaction on the board, zinc plus Cu2 plus, it means 2 electrons has been removed from copper. We are getting Zn2 plus plus Cu, it means here now from zinc electrons have been removed and copper we get it in the solid form. Okay, so here you all know that yes, if electrons are being removed, oxidation is being taking place. If electrons are being added, reduction is being taken place. Okay, so in case of zinc, oxidation is going on. In case of copper ions, reduction is going on. Let us see the experiment taking this beaker. Okay, in the beaker, what has been added? Copper nitrate. Okay, and here in this zinc rod has been placed. Okay, so initially we see that the color of this solution of copper nitrate is blue in color. Okay, but the intensity of the blue color is reduced after some time. Okay, and finally we see what? This copper ions are deposited on this what? In this zinc rod, and here the blue color of the solution has been vanished. Okay, and the intensity can be noticed by step. Okay, so why this has happened? What is the reason behind it? Actually, what has happened, this zinc has lost the electrons, okay, and those electrons are taken up by copper and it is getting reduced. So why the question comes here, why the zinc has lost the electrons and copper has taken the electrons? Actually, this can be understood by electrochemical series. Here we can see what? The potential of zinc to lose the electron is more than that of copper. Okay, so like if we are talking about potassium, sodium, okay, going on calcium, potassium, sodium, calcium, magnesium, okay, when we are going on in a series, we are seeing that yes, what happens? If we go on in this manner, aluminium, okay, in this manner if you go on, you will be seeing that yes, those who have got more potential, okay, can lose the electrons more easily. That is the reason over here that zinc rod has got, or the zinc element has got more potential to give the electrons rather than copper. So this is all for today. Good day. Take care.